Hi everyone, this is Kevin, and here's my presentation on Dijkstra's algorithm. Dijkstra's algorithm is an algorithm for finding the shortest path between nodes in a graph, which may represent, for example, road networks. Algorithms have a long history. Algorithms were used in ancient Greece. Two examples are the Sieve of Aristoteles and the introduction of arithmetic by Nicomachus, and the Euclidean algorithm. Babylonian clay tablets describe and employ rhythmic procedures to compute time and place of significant astronomical events. Tally marks used through Babylonian, Egyptian, and Roman systems eventually developed the abacus counting book. Tally marks later appear predominantly in unary numeral systems of arithmetic used in Turing machine and post-Turing machine computations. Dijkstra's algorithm can be used to develop routing tables for mesh networks and to figure out how to minimize the amount of wire needed to connect pins on the back of a panel of a machine, for example. Here I will go through a quick explanation of how to use Dijkstra's algorithm to find the minimum weight paths between vertices on a weighted graph, i.e. find the lightest or least costly route between vertices on a graph. This exploration will be A-centric because I will start with A. On the weighted graph here, my vertices are labeled in black letters and the weights of the routes are in red numbers. So I'll start with A, and the cost to get to A is 0, so I will mark that here. We use subtext to indicate the vertices that we last came from. Next is, can I get to B from A? The weight of 8, yes, I mark it. Also, I box this value here because we know that's the cheapest route, so I don't have to re-look at that column or that path. Can we get to C? Yes, with a weight of 2. Can we get to D? Yes, with a weight of 5. And E, F, G, and H are not connected directly, so we will label them as undefined with infinity symbols. We looked at this route, this finished column, and determined that 2 is the least costly vertex to get to, and so we will now look at vertex C and bring the 2 down. And we can also box that because we know that that is the cheapest route to vertex C. And we'll indicate on the left here that we're looking at C. So can we get to B from C? No, we cannot, so the 8 will carry down. Can we get to D from C? Yes, 2. So 2 plus the weight to get from C to D is 4. Now, the cost of 4 is cheaper than 5, so we re-establish the cost of getting to D from A as 4, and that is actually one of the tricks or valuable components of Dijkstra's algorithm because it can determine a cheaper route, and then after that we can move on and look at the other ones, and we'll see, and we go through this process on and on and on till the end. So what we have here is, with the boxes, identified the cheapest routes to take to get to the various vertices here. So for example, if we want to get to E, the cheapest route to get there is 5. To follow the path, we go from E to D, D to C, C to A, and then we're back where we need to be. Pseudocode. Most importantly, Dijkstra's algorithm, the key component is after here, we've initialized and set all unknowns to infinity. We iterate through, and right down here is the key part where basically if the algorithm determines the distance, weight, or cost, for example, between the current vertex under evaluation and its neighbor is cheaper, then the algorithm will replace the distance with the alternate cheaper route. The big O notation for Dijkstra's algorithm can change depending on the complexity of the data set, i.e. the way that the vertex set is implemented. Because Dijkstra's algorithm does not recheck the shortest routes to the vertices that it has already visited or confirmed, and Dijkstra's algorithm, big O, is most likely some combination of logarithmic O log n and linear O to n. The vertex implementation may produce a best worst case runtime denoted as O e log v, where v is the number of vertices and e is the total number of edges. Here are some references, and that is my basic rundown of Dijkstra's algorithm. Please let me know if you have any questions. Thank you.